All right, here's our second part of lesson 2. It's kind of, the fancy word is called non-rigid transformations. But in layman's terms, or kind of normal, it's called stretch or shrink. So again, there's kind of some basic rules where, again, we can have a vertical stretch or a vertical shrink. So our vertical stretch would be something like, say we took our function, okay? So again, we're always using y equals f of x. And if I multiply my function by c, it's going to change, okay? So again, this is the part that's different. Now, this is a little different where it's going to stretch if c is greater than 1, okay? So that's when we're going to get a stretch, is when c is greater than 1. We're going to get a vertical shrink, or kind of like smush it together, when we have the same thing right here, except c has to be in between 0 and 1. Let me make that, they kind of look the same. So let's do an example, and I think it will make more sense. So I'm going to take out my Desmos calculator, and I'm going to take the absolute value function. So let's just say the absolute value of x. All right, this is the one that kind of looks like a V. And if I wanted to stretch the absolute value function, again, looking at my notes, I have to multiply it by a number that's bigger than 1. So let's say 3 absolute value x. It's like I'm grabbing the top. It's like I'm grabbing the top of my graph and I'm pulling it apart. I'm stretching it out. So it's much steeper now. Whoa. Okay, you can see this graph. We just got some massive numbers there. There it is. Okay, it got stretched out. Now, what if I wanted, again, to kind of vertically shrink it? If I wanted to vertically shrink it, I'd have to pick a number that's in between 0 and 1. So if I notice, again, here's my parent function, and I want to shrink it, well, I'm going to use a fraction. I'm going to use the fraction 1/3. Oops. Close that. And I'm going to take the absolute value of x. So again, it's like I'm smushing it together. I smushed that red graph together so that it's going to be flatter. I vertically shrunk it. Okay. So we can use that, like that's an example of vertical stretch or vertical shrink. We can also do horizontal stretches and horizontal shrinks. So it's going to be similar. Horizontal stretch. Okay, so my horizontal stretch is going to be a little bit different again. So I have the same function, h of x equals f, but again, this time I have to manipulate it inside of my function. So I'm going to take c and I'm going to manipulate it inside my function. And I can also have a horizontal shrink. And it's basically the same rules. Again, c has to be greater than 1 for it to stretch. And if I did the same thing, h of x equals f of c of x, or f c times x, but c is in between 0 and 1. That looks like the same thing 3 times. C, there we go. It's going to horizontally shrink. So we could try a function to kind of show that. So if I take my square root function, whoa, not pi, no. This is my normal function, way too big. All right, there we go. Now it's back to normal. And if I wanted to horizontally stretch it, I would put that number, maybe call it 5x, okay? I'm horizontally stretching it out. Whereas if I wanted to make it into a shrink, I might say, well, let's do 1/5. Oops. One-fifth x. And again, that's going to horizontally shrink it. All right, so just one more example of non-rigid transformations. Let's say that we take 2 subtract x to the third power. So we're going to get a function that looks something like this, okay? So again, my original function is 2 subtract x to the third. But what I want to do is I want to take f of 1/2 x. So again, I'm going to think, if it's inside of my parentheses like that, if I'm looking at these rules, that looks to me like because it's in between 0 and 1, it's probably going to be, or not probably, it is going to be a horizontal shrink. So again, I have to do that to the entire problem. So I'm going to say, all right, equals, because I can do it algebraically as well as on my calculator. So I'm going to say every time I see an x, I'm going to multiply it by 1/2. And again, it's still to the third power. And so when I do that, just a quick refresher, again, 1/2 times 1/2 times 1/2 is going to give me 2 subtract 1/8 x to the third. So if I were to type that into my calculator, again, here's my original problem, but I horizontally shrunk it by 1/2, 1 divided by 8. Nope, gotta go over with x to the third power. That's what my graph would look like. So again, it's a little bit different, but that would be an example of a horizontal shrink. So really, you really just have to pay attention to the rules and understand where are we what are we changing? Are we multiplying outside of it, outside of our function? Because we're going to get one of these. If we're multiplying or doing something inside of our function, then we're going to get one of these ones.